This is Module 2, Lesson 1. We're going to look at properties and changes. We're going to use these as we go throughout the rest of our lessons in this course, so it's important that you understand the difference between physical and chemical properties and physical and chemical changes. Don't forget that this is a video, which means that you have the power of video. You can pause things, you can replay them until you understand them, or if you didn't get it the first time. So use that. I know this is fast, but you have the controls at your fingertips. All right. First, we're looking at two different types of properties that are not what we just said. We're looking at extensive and intensive properties. The definitions are on the screen. You can read these. The key here for extensive is that if the amount of matter changes, then it's an extensive property. So if you have a greater volume or a greater mass, your numbers are going to change. That's an extensive property then. Intensive, basically, it doesn't matter how much of it you have, that property is related to the substance. So if you have a diamond, it doesn't matter if the diamond is 1 carat or 10 carats, the hardness doesn't change. Or if you have a cup of water versus a gallon of water, the boiling point of the water is still the same, but the volume of the water is different. So ask yourself the question about, if color changes, if I have more of the substance, does color change? And if the answer is no, then it's intensive. And if the property does change, then it's extensive. Special case here with density. Wanted to point out to you, if you remember from Module 1, density is mass over volume. Well, if you have more mass, you'll also have more volume. This doesn't change. So if you have a piece of wood that is this big and you have a piece of the same wood that is this big, they will both have the same exact density because their mass and their volume will change proportional to each other. If the mass doubles, then the volume will double. Density is an intensive property, and most of my students want to try to make it extensive, so please don't be fooled. Okay, physical properties are next. You can read the definition. If you observe these properties, you still have the same exact substance. So if you observe the color of a piece of paper, then it's still paper. If you measure the size of a table, it's still made out of the same material. A couple of these that you may not know. Malleability is the ability to hammer something into thin sheets. Ductility is the ability to draw something into a wire, like to pull it into a wire. These are very common properties of metals. Luster is the shininess of something. If it's high luster, it's shiny, and if it's low luster, it's dull or matte. Viscosity is kind of like the thickness of a liquid, flow rate. Something that is very viscous, and you would spell it this way, something that's very viscous is very thick, and something that has low viscosity or isn't viscous is very thin. So like water is not viscous, but honey is very viscous. The rest of those, I think you should be able to define on your own. There are others, other physical properties. I just gave you like some very common ones for chemistry. So we'll practice identifying those in just a little bit. A physical change occurs when you change one of those properties, but you still don't change the composition of it. So if you take a piece of paper and you tear it in two, you didn't change what it was made of. If you grind sugar up into smaller chunks, it's still sugar. It's still made out of the same number of carbons, hydrogens, and oxygens. If you boil water, you just go from having liquid water to gaseous water, but the key is it's still water. Same thing goes for the other phase changes. These right here are all phase changes. Breaking something, cutting it, you're not changing the material that you have. Now, chemical stuff, on the other hand, you actually change the substance. So if something rusts, you are actually doing a chemical reaction where you are creating a whole new substance. A nail that rusts is no longer iron, it's now iron oxide. If you burn something, you are actually doing a chemical change. So for example, if you burn methane, I know we've not looked at these completely yet, but if you burn methane, you are combining methane, which is right here, with oxygen, and you are actually changing methane and oxygen into carbon dioxide and water. This on the right side is not what you started out with. Oxidation is a fancy word for rusting. So there's other ways of oxidizing. Think of copper, like the Statue of Liberty, how she turned very green. And we could add another one over here, which is the ability to react. So, for example, you know that baking soda and vinegar react together. You've probably seen that. So, the ability of baking soda to react with vinegar is a chemical property of baking soda. If you put sugar with the vinegar, you wouldn't see all of those bubbles and things like that. So, you know, certain substances, they don't react with each other. So, the ability to react would be a chemical property, because if they do react, well, you get a new substance. So to decide the difference between chemical and physical, you need to ask yourself, does it make a new substance? If it doesn't, it's physical. If it does, then it's chemical. Okay, likewise, chemical changes are when you change the composition of a chemical. And there are some clues. That baking soda and vinegar example is a really good one here, where it has production of a gas. So if you put baking soda and vinegar together and it bubbles and fizzes, that's a pretty good sign that there's a chemical change taking place. Alka-Seltzer and water is another good example. A change in color. Some examples of this would be fruit ripening, like tomatoes, they go from green to red as they ripen, or bananas go from green to yellow, eventually to like a brown color as they actually kind of rot. Heat given off or absorbed, so like those hot hands, hand warmers, you open them up and you shake them and they get all, like they get really warm. That's a pretty good indication that there's a chemical change taking place. Or like the one-time use cold packs, if you get hurt, those get cold. So if something gets hot or gets cold, most likely there's a chemical change going on. And this one's kind of a weird one. It's formation of a precipitate. If you mix two liquids together and a solid comes out, it looks kind of like magic. That's a pretty good sign too that a chemical change was taking place. You made a new substance. You made the precipitate. So you need to know these particular changes. So some things that also count as chemical changes that you might not think about. Now, these are not clues. These are just some additional chemical changes. So like from the first one, if the ability to oxidize is a chemical property, then oxidation is a chemical change. Burning is a chemical change when something catches on fire. Cooking, baking, you're actually physically, you're physically changing it because it looks different, but you're actually chemically altering the structure. So cooking and baking are chemical changes. Decay or decomposition, those are chemical changes. So as those bananas we talked about go from green to yellow to brown, they're in the process of decaying. That is actually a chemical change. So, you know, think outside the box with these last two, because I've got those in some of my examples. Okay. I wrote one of these for you a while ago. I wrote this one, CH4 plus O2 yields CO2 plus H2O. This was our methane burning. Okay, products are over here on the right. They are the things that come out of a chemical reaction. It's not going to let me change colors here. For example, right here. Those are, they're produced, they come out of it. These on the left side, these are the reactants. They're like your starting ingredients. So if you think of this kind of like a recipe, the reactants go in, they're usually on the left of the arrow, and the arrow points towards the products or the things that come out. Now, law of conservation of mass. What that means is that we cannot create more things than we started out with. Like, for example, we have one carbon, one C right here. There's one C on this side. There's 4 H's, and here there's only 2. So what that says is that we can't do this. And so later in this class, we will learn how we fix that. We'll have to make it balance. But you cannot destroy 2 hydrogen atoms. Likewise, we have 2 oxygens right here. Here we have 2, and another one makes 3. So according to this, we magically created an oxygen. Excuse me, and it doesn't work that way. So we will have to deal with this later. It does also mean that if we have to have equal numbers of these on both sides, that, like, for example, if we start out with 20 grams of reactants, then that means we have to end up with 20 grams of products. So, you know, Whatever you start out with, you must end up with, and I don't want you to worry about balancing right now. All right, our last little bit is about states of matter. You have learned about these in middle school. The main thing that I need you to do right now is focus on like the shape, the volume, the kinetic motion, and easily compressed. You can read through this. Definite means it doesn't change, and indefinite means that it does. So you also need to know like what the particles would do. So like the particles of a solid are in fixed positions, and they do move, they just vibrate. You know, the particles of a liquid can kind of flow freely past each other, and then gases, like, they move all over the place. They go wherever they want to. There are two additional states of matter, plasma and Bose-Einstein condensate, for you to know. You can read the definitions there. This one is the most recently discovered right here, and as you can tell, Einstein had a little something to do with this. And then know the compressibility of each, that basically these two have particles so close together that you just can't smush them any closer. But a gas, they're so far apart, well, they're smushable. All right, it's practice time. You have a practice in the next part of the module, so go to that and see what you got out of the lesson. If you have questions, then please ask me.